Correcting division patterns. Common Core MA 322C and MA 4N5. And what we're going to do today is solve multiplication problems using rectangular arrays, number patterns, skip counting, and repeated addends. And this is just a standard that kind of talks about what we're doing again today. But the main idea is that we're going to relate division to number patterns and models of groups and rectangular arrays. So, when you look at your notebook page, what you should have is your learning goal with the full Common Core standard, the title, the learning goal in your own words, and your what I know. There's no foldable manipulative for today's notes, so you should be all set when it comes to that. So you should just have your blank piece of paper with your learning goal at the top. And my learning goal took me about 6 or 7 lines, so I'm just going to skip to here. And now we can start our notes. So what are division patterns? Well, division patterns have to do with when you add a 0 to the end of the dividend, the quotient ends with one more 0. So let's write that down. Quotient will have one more 0. And you may be a bit confused, but let's look at some examples and hopefully that will help. First we'll do 30 divided into 6,000. If we start with 6 divided by 3, we know that 6 divided by 3 is equal to 2. If we beef it up a little and we say 60 divided by 30, each of those numbers have been given a 0, but my quotient is still 2. If I have 600 divided by 30, I have an extra 0 in my dividend. So my solution, my quotient, is going to have an extra 0, right? So now 600 divided by 30 equals 20. Lastly, 6,000 divided by 30. Again, I have 2 extra zeros as opposed to my divisor, so my quotient is going to have 2 zeros. It's equal to 200. So that is a significant pattern that is really important to notice. As the zeros in the dividends increase, the 0 in your quotient will also increase, right? So let's just shrink that down a little bit. You should have plenty of room on your paper, but I'm not writing as small as my notebook lines. Let's do one more example like that. So how about 20 divided into 80,000, right? Once again, I'll start off. 8 divided by 2. 8 divided by 2 equals 4. 80 divided by 20 equals 4. 800 divided by 20, remember I'm increasing zeros, equals 40. 8,000 divided by 20 equals 400. 80,000 divided by 20 equals 4,000. Now, 20 was my divisor, which is why I consistently kept that 20 as I increased. But I had to add zeros to my dividend until I got the correct number. That's what brought me to the accurate quotient, my accurate solution, which is 4,000, right? So one other thing I want to talk about today is how to check your division problems. Now, many people do long division, and it's frustrating because it seems like you do all this work and you do all these steps, and when you get to the end, you might be wrong. So in order to practice checking our division problems, we're going to use multiplication. So let's work backwards. Let's start with a long division problem and say 16 divided by 1,535. Let's do our division first. 16 does not go into 15. 16 has to go into 153, and it does that 9 times. 9 times 16 is 144. And when I do my subtraction, I get 9. I bring down my 5. 16 goes into 95 5 times. 5 times 16 is 80. Subtract, and I have 15. I have no more digits in my dividend to bring down, so 15 is a remainder, okay? So let's work backwards. First, I need to start by identifying the pieces here, okay? So 16 divided into 1,535 equaled 95 remainder 15. So what I should be able to start with is say 16 times 95, and that should get me somewhere close to my 1,535. So if I do out all that multiplication work, which I've already done in my notes, but you may do in your notes, you get 1,520. Now that doesn't equal 1,535 just yet because we haven't accounted for the remainder. So if I add that 15 remainder, I get 1,535. This number is equal to my dividend, and therefore my long division was correct and I got the right answer. So that's a great way to check your long division problems. You're going to divide, multiply the quotient by the divisor. If there's a remainder, add the remainder. And without the remainder, just compare the product to the dividend, or the sum to the dividend. If they're the same number, then you're correct. My notes are a little more complete than what I've given you today. If you would like to go through and copy down the remaining examples, you may, but it's definitely not necessary. I think division patterns are something that most of us will understand rather quickly. Please make sure you do fill in the what I learned, complete your proof, which are 2 long division problems that I would like you to check the answers of. So you're going to use this method, the how do I check my division problem method, to do that. And finally, complete a thoughtful, creative reflection prior to our next class.